Hello students, today we're going to talk about sets and tuples. So far we've discussed two different types of collection objects, strings and lists. Remember, strings are a primitive data type in Python. They're used for a collection of characters to make a piece of text. Lists are a more complex data type called a data structure that can be used to store other pieces of information. Today we're going to be talking about two more data types, sets and tuples. Both of these, like lists, act as simple data structures, objects for storing collections of data. However, they each have distinct properties regarding how they work, and they're different from lists in this regard. A set is an unordered collection of unique, immutable values. Now, there are three important parts to this. First, make a note that a set cannot contain duplicate values. Each item in a set must be unique. Now when we look at a set in Python, we store it within curly braces. So you can see a piece of code here where we create a set X and set it equal to the two strings hello and world. Now sets are not ordered. Elements may appear in any order, and you cannot reference elements by an index. If we consider the set 14 to 87, 91, 16, and 5, if we were to add the number 3 to this set, then it could appear anywhere in this list. It would appear wherever there was free memory available to it. Because of this, sets are one of the fastest data structures to use when you're able to use them. Sets can also be created by invoking the set function on another iterable, such as a list. So for example, if we say we want to create a set called set names, then we can use the set function and pass in a list of names. In this case, if we say Alice, Bob, Carl, Bob, and Alice, we will set the value set names equal to the set Alice, Bob, and Carl. Again, they have to be unique. Since Bob and Alice both appear twice in the original list, the duplicates are removed. Now sets are immutable, meaning they can be changed, but since we can't reference items within them by index, insertion and deletion are done using different operations. The add function is used to insert an element to a set. For example, if we take the set 1, 2 and we want to add the string a to it, we would use mySet.add, as you see here. We could then print out the contents of the set and see that a has been added to it. Again, a could occur in any position, and depending on how you run this on your computer, it may not be at the end of the set. Now there are two ways to remove an item from a set. There's the discard function and the pop function. The discard function is used to simply remove an element. Pop is a little different. Pop is used to remove and return an element. Again, if we create the set in mySet, and there's a typo in the slides here, but if we say that mySet is equal to 1 to a, as we created in the last slide, then we were to say mySet discard a, we would then get just the 1 and the 2 back. The a would be removed. If we were to use the pop function, we could then set that equal to some new variable, in this case val, and mySet would lose the 1. It would be removed from mySet, but instead it would be stored in val. This is what we mean when we say it removes and returns. It removes it from the set. It's no longer present in the set, but because it's returned, we're able to set it equal to a new value. If we were to set val equal to something with a discard function, we would get a none type object back. There wouldn't be anything returned from that. So we would see the special null value none there. Now sets have a number of useful things that they can be used for, but the most common is probably membership checking rather. So for example, suppose you wanted to create a list of unique unchangeable usernames. In this case, a set is better than a list. You can add things to the set of usernames, you can remove them, but you can ensure that no two people have the same username. And you can also ensure that a username can't be changed while it's in the list. You can remove and add a new one, but you can't change one that's already there. Sets, because as I mentioned earlier, they're one of the more efficient data structures, can also be used to check for membership in larger collections. So consider a list of all the authors that might appear in a library. A library is a potentially a very large collection of books, possibly hundreds of thousands of books. Um, and many authors write more than one book. In a library that has 100,000 books, you might only see 20,000 authors. Um, and so we can use a set to list off the authors, and we would ensure that if we add a new book to the library, if that author's name is already in that set, that we won't get a duplicate record there. And because it's going to be much smaller, it would allow for a much faster lookup. Now I want to take a step back here and mention one more thing about a set. We've talked a little bit about how it's unordered and how it's unique. It's also worth noting that the elements of a set must be immutable. This is just as a technical note. It's impossible to put something like a list as an element in a set. So if you try to do that, you'll receive an error that the item is not hashable. And this is due to how elements in a set are looked up using operations called hash operations. The second type of data structure, collection data type that I want to talk about today is called a tuple. Tuples also work very similar to lists, but they have some different properties as well. And the big difference between a tuple and a list is that tuples are immutable. Remember, we talked about lists being mutable, how we can reference an item in it by its index and then change the contents of that item, or add or remove it. Tuples are a collection that works in the same way, and they are indexed in the same way a list is. But items cannot be changed within a tuple, nor can they be added or deleted from a tuple. This makes it particularly useful when we don't want data to be changed during an operation. Now, to create a tuple, you use the syntax of surrounding a list of comma-separated values by parentheses or parens. So in this case, you can see we're creating a tuple called myTuple, and we're setting that equal to the string a, the number 4, the string hello, and the Boolean value true. Like a list, elements of a tuple do not have to be the same type, so you can have a mixed tuple like this. And they can also be referenced by index. So if we reference myTuple sub 2, that would go to the 0, 1, second index, which is the word hello. It would return the string hello. Now, Python has a powerful form of multi-assignment called tuple assignment. This is one of the big draws of a tuple in Python. Tuple assignment allows you to take a tuple and assign each value in it to a distinct variable. So consider the case where we have some database that contains a list of names, majors, and graduation years. And we want to iterate through all the records in this database. Well, we can create a tuple representing one record, and then use a single line of code using tuple assignment to assign it to each value in that record to distinct variables. So in this case, we create a tuple for Jacob, who studied CSIT and graduated in 2012, and we can say we're going to set the variables name, major, and grad year equal to myTuple. And then we can reference those variables as we would any other way. So if we wanted to print out grad year, in this case, it would print out 2012. Again, this is especially helpful when data is loaded into your program from an external source, such as a database or file. And it's helpful for two reasons. First of all, you can use tuple assignment in order to create the variables you want to use, and then use those and have easy to read and easy to understand code by using meaningful variable names to reference the different parts of the data that you're loading in. The second thing that makes tuples so uniquely well suited to this goes back to what we said previously about how tuples are immutable. Once they're created, they can't be changed easily. You have to create a new tuple. So we can ensure that once we load data in, the data in that tuple is still the same as it was. It hasn't been corrupted or manipulated by some typo or previous bug in our code. The original tuple is still in its original state. Now, the second place where we see a lot of use of tuples in Python is using tuples as a return value. We've talked about return values in our previous studies and looks at functions. And if you remember, we talk about how a function can only return a single value. And that's true, but we can work around it a little bit by using a tuple. Because a tuple is immutable, it can act as a return value. And so say we have some function that we need to return multiple values from instead of just one. By placing those values into a tuple, we can return multiple items from a single function. So if you look at the code here, we want to find out the circumference and area of a circle with radius r, and we want to do this in a single function. Now obviously we could write a circumference function and an area function, but in this case we want to do it with just one function. So we pass in our radius r as an argument on our function, and when it comes in, we perform the correct calculations to determine the circumference, which we store in the variable c, and the area, which we store in the variable a. We can then return the tuple c, a, which contains both of these values. And so using a single function, we can actually return two pieces of data that we can then reference in the calling function by their index.